Hi, greetings. We're looking at population standard deviation, and this is an example. So I'm going to just get right to it. And please note that we're looking at all the values in a population. We're not looking for a sample of the values. Okay, so that this makes a whole lot of difference. So the formula will be different. Alright, so before we go on, just remember to subscribe, like, and share. Now, find the population standard deviation of the following data set. So this is the example that we'll be working with. How many values do we have in the data set? You said 6, that's correct. Now, the first to calculate the population standard deviation, we need a formula. And the formula, as you can see right here, we have a lowercase sigma. So that symbol, this symbol here is the population standard deviation, right? It represents the population standard deviation, which will give us an actual value, a numeric value. It is a lowercase sigma. It is the lowercase sigma, and it is the standard deviation of all values in a population. We also have the uppercase sigma. So we have two sigmas, a lowercase one and an uppercase one. The uppercase sigma, or the capital sigma, is the summation of a set of values. So we're going to add up a set of values. Now, we're not going to add up these values as in being the summation symbol we'll be using. No. Alright, we'll see as we go on. This x is the data value, alright, or the data values. Okay, each value in the data set is represented by, or x represents each value in the data set. The mu, this is actually mu. Looks like a u. Let's put an m next to that and we say mu. Alright, mu. It means all the values, the mean of all the values. The mean of all the values in a population. So the mu, we're going to calculate the mean. Alright, we don't have the formula for the mean in this, so we're going to have to find that out. Alright, and then once we subtract the mean from each value in the data set, then we're going to square the result, and each result that we get, we're going to add them up together. In other words, we find the summation and then divide by the number of values in the data set. And after that, we're going to do the final thing, which is to square root that answer. Alright, so let's get to it. And as I explained before, this is the mean. We refer to it as mu. Alright, so mu, or the mean, is equal to the sum of each value, well, the sum of each value in the data set. So we're going to find the sum of these values, each of these values. Alright, or we can say we sum of all the values, I should say. That's better, sum of all the values. So each value, we're going to add them up, and that's what we say, the sum of all the values. So we have 18, 19, 19, 25, 28, 35, and we get 144, and we divide by the number of values, we get 24. So that is the mean. So we're going to create a column of each value, each of these values, 18, 19, 19, 25, 28, and 35, and we're going to subtract the mean from each of those values. So here we have the table, and this table, what this table does, it helps us to actually carry out this part step by step. Alright, so we have the x. So first we take x, which is each value in the data set, and we subtract the mean that we found earlier. And once we're going to do that for each value, we're going to subtract the mean from each value, which is what this column stands for. All those, the result will go into this column. Alright, that result we call the difference going into this column. And then we're going to square that each of these results. Alright? So let's go on. So we have the mean that we calculated. We fill it out under that column. And the next step is to take the 18 and subtract 24. Take the 19 and subtract 24. Take the 19, subtract 24, 25 minus 24, 28 minus 24, 35 minus 24. Okay, so let's see what we get. As you can see, we have 18 minus 24. What should we get? Not positive 6, but negative 6. And then we're going to do the same for the others. Negative 5 should get negative 5 again. Positive 1. They should give us what? Positive 4. The next one should give us positive 11 because 35 is bigger. Alright. Okay, we have a negative here, but this is incorrect. This should be a positive. Won't be able to change it at this moment. But this should be a positive. So we just take it as a positive 11. Right, so next, what we're going to do? Well, let's see what this tells us to do. It said we're going to take the result of x minus mu, which we have in this column, and we're going to square that result. So x minus mu for the first value squared is going to give us what? Not negative 36, but positive 36, because the negative times negative will be positive. When we square negative 6, we're seeing negative 6 multiplied by negative 6. Positive 36, so all the values will be positive. Positive 25, positive 1, positive 16, and the next one will be what? Yes, 121, negative or positive? It should be positive. So despite we have a negative, the reason it will work is because negative 11 to be squared, or negative 11 squared is the same as positive 11 squared, and that will be 121. Okay, just remember this should be positive 11. Alright, so what we're going to do next, we're going to find the sum of these values. According to the formula, we're going to find the sum of all the values being x minus mu to be squared. So we're going to find the sum of all these values, and we get what? 224. If you use a calculator, add up all of these values, you get 224. So we have done what we should for the numerator. So what goes on top here should be 24. What goes in the denominator? If you said 6, you're correct, because we have 6 values in the data set. And so we write the square root symbol, replace the top, because we have carried out the rule step by step. We got 224, the n is 6, and to 224, let's do that in our put that in our calculators. 224 divided by 6 will give us what? That will give us 33 1/3, or 33.33 recurring. 37, I should say, 37.33 recurring, or 37 1/3. When we square root that, we get 6.1. In your calculators, you will see 6.110100, but we're just leaving it at 2 significant figures, or we can say at 1 decimal place. So this will be our population standard deviation. Remember to comment, like, subscribe.